Sure.
You got it.
Thanks, Doctor. Okay, so hi everyone. So sorry for the delay, and yeah, so we finally solved the technical issue, and we can have our workshop now. So first of all, I'm Ziyan. Me again. I will be the MC or moderator for tonight's event. And before we begin, maybe I can introduce our speaker for today. So our speaker is Dr. Lau, and maybe I will use my way to introduce him. So actually, I get to know Dr. Lau is back at 2020, which is when the COVID-19 pandemic broke out. During that time, I get to know him through the Corona Tracker. And yes, he's a founder behind the coronatracker.com, a website or a web app that try to use natural language processing, artificial intelligence to combat the COVID-19 pandemic. And since then, I've been following him on Facebook and LinkedIn. On his Facebook and LinkedIn, he share a lot of career tips on data science and also about sometimes about marketing, and also he helped people to review their data science resume, which is very great. And yeah, I think that's enough. That's enough for me. And the floor is yours, Dr. Lau.
All right. Thank you very much. Thank you, Ziyan. So, without further ado, let's get started. Let me share my screen. And Ziyan, let me know if you can see my slide.
Yeah, I can see your slide.
Okay, good. Hey, good evening, everyone. So sorry for the slight technical delay. If we are in JB right now, I'm in JB. So we had a thunderstorm earlier on, right? So the weather affected a little bit. Yeah, doesn't make sense, even though we are using fiber optic, but that's the truth. Okay, so tonight we'll talk about the skills that will get you a data science job after graduate. So I'm happy to see that many of you during these long weekend period, and for those of you who are back at your hometown, who you had a good holiday, and I've assumed that most of you here tonight, right? You are talking, you're interested to know more about what is the life after your graduations and whether you want to become a data scientist. What should you do? So this is an interactive session. So let me know if you have any questions, and then I'll answer to them. Zivian, so how do I see their comments and feedback? Is it through the StreamYard?
Yes. Yeah, you can through the stream. Yeah, you can see their comment.
Okay, sure. And then I'll do that from time to time. Yeah. So let's get started. Now, when it comes to data science, right, people always have different kind of views on data science, especially when you go and look for jobs. I can frankly tell you that your resume play probably about 10-20% of the role, and then most of the companies out there, they don't know why are they hiring a data scientist or data analyst. Probably for data analysts, yes, they can tell you why, but for data scientists, most of them, they don't have a clue. In fact, when people hire us, whether is it for consulting or whether is it for like they hire our students as data science position, right? They will just say, oh, you're a data scientist, right? Or your teacher is Dr. Lau or whatsoever. You're very smart, right? Okay, tell me something that I don't know. That's usually how it goes. So we are still at the very, I wouldn't say at the early stage. It's rather infant stage at people trying to use data to make decisions and to make their business operations better. Even we ourselves, when we enter a business, we are that data savvy, but we don't really like die hard using data to make decisions because there are other external factors, but we are moving towards that. So the three things that, oh yeah, another thing I would like to add is HR who approach you, right? Basically, you look at their job ads. Don't worry too much about the things that they say because they usually copy and paste the job descriptions, one from elsewhere. So you have to remember there are three key things in data science. One is mathematics and statistics. One is coding, and one is domain knowledge. So you can let me know in the comment section which is your background. Do you have a technical background? That means you know how to code. It doesn't matter what programming language, okay? Or you can let me know whether you are from a mathematics and statistics background or engineering background. Or if you don't have either of that, what is your background? Psychology, business, accounting, pharmaceutical. Let me know. I'll check it out. Okay. Com science, data engineering. What about the rest? Mechatronics engineering, currently working as an R&D engineer. Okay, so keep those comments coming. Now, if you look at this one, right, data science is unique in its own way because it's not just uh, a like traditional life sciences, let's say biology. Okay, we study a lot. Even for biology also, you don't just focus on study humans, right? You study humans, you study animals, and there are different types of animals. And for chemistry, you study a lot on the atoms, and then for physics, you study the movement, okay, the movement of the universe, and you can apply it all the way from a ball to your Earth to the Mars and the universe, basically, right? For data science, it's the same too. We combine three different knowledge together: maths, statistics, coding, and domain knowledge. So for coding, right, you just have to master two languages. There are outside there, a lot of people will say, "Oh, you if you don't have a technical background, it's very hard to become a data scientist." Yeah, yes and no, but you just have to master Python and SQL. Python is because okay, so if you learn R in your uni, right? In your uni program, I know some of you, like let's say you're from maths background, statistics background, you do R. R is equally good as well. In some areas, R is stronger than Python. But what is good with Python is the automation and also the capability to take it to production. So one thing that's important when you build a model is how do you use the model. Let's say I build a model that can predict the weather of next 3 hours, right? Okay, or the temperatures, humidity. But if you can't take this to an API, to a web application, people can't use that. People can't turn it into something that's useful or usable. So it's equally, not to say equally, but to a certain extent, worthless, not too much of the value. Yeah. But if you do it with Python, then you can easily turn that into a web application. So that's one thing. And the other one is SQL. SQL is very important, structured query language. If you have not heard of that, in layman's term, SQL is a language that allows you to communicate with a database, to manage a database. You want to insert data, you want to retrieve data, you want to update data, you want to delete data, you have to use SQL. Most of my students, when I say students, they are not like uni graduates like you guys. They are, I mean, some of them they have bachelor degrees, some of them masters or bachelors, uni teachers. But my mentees, like my trainee, right? They get a job in companies like Touch and Go, Shopee, Food Panda, or even Grab, just by mastering these two skills, and they dare to go out and hunt for jobs already. Yeah. So I want you to see data science as a tool, right? So these two languages are tools that help you to collect data, clean data, analyze data, build predictive models, and then you do presentation. You present your results. These are the tasks that data scientists do on a daily basis. Every day we do this. Yeah. And as a tool, right, you can see it like a drill, okay, or basically a drill. When a carpenter owns a drill, he can use that to make furniture. And if a contractor, if a builder get a drill, right, they can use it to build a house. Yeah. But it doesn't mean that we shouldn't own a hammer or shouldn't own a drill at home. We can start from fixing small items. I don't know, drill a hole on the wall and then start hanging your pictures and your certs, or build your own cupboards like IKEA cupboards. That is something that a small achievement or small wins, and that does not stop you from owning a cupboard. Sorry, owning a drill, right? Yeah. So, and you get better at using these tools as time goes by. So that's number one. Now, number two, mathematics and statistics. When it talks about mathematics and statistics, of course, I mean, you guys are engineering students, so your math have to be better than me. Otherwise, there's something wrong. And if you guys are com science student, your math has to be better than me as well. I'm from IT background, and I personally don't like maths until I did my PhD. So my supervisor told me that, okay, I told my supervisor that I would rather write code than write mathematics equation. And my supervisor said, if you only know how to write codes, right, you can't get your PhD cert. So that's the reality. But then, as I finally give give up, give in. I gave in, and then I realized that maths and data science or encoding are pretty much the same. Yeah, it's about algorithms, it's about logic, it's just writing in different expressions. And for data science, if you don't come from a technical background, the maths and stats that we use in data science, right? I would say mostly around regressions, discrete mathematics, probability theory, descriptive analytics, and look at the distributions. So let's start from the regressions. Regressions are things like logistic regressions, linear regressions, and these are the things that help you to predict or forecast the future values. And discrete mathematics are something for you to count. Okay, you learn how to count permutation and combination. You know those NC5, and what, 5C. But for C and P, computation and permutation, these are the two things. And if you think discrete mathematics are easy, you try to do some combinations that is with Chinese wedding table. So there are 10, just typical Chinese wedding will have 10, 15 tables, right? And each tables will have 10 seats. So you have 150 slots for you to put people there. But there are a lot of criteria, conditions, external factors that will affect your seating plan. For example, these three people, they are good friends, so they have to sit together. And then the other two of your cousins, they are family and they're bringing two kids, so they have to sit together. And then this auntie and that auntie, they are not getting along too well, so they cannot sit together, and things like that. Now, if you try to model this using any sort of programming language, right, you will notice or you'll realize how hard is it to do that. It's super difficult to do that. The third one is probability theory. So probability theory, if you remember, like in SPM, right? We were tested. There's a bag of balls, and there are 7 blue balls and then 3 black balls. And take one of the ball out. What's the probability that this ball is red color? And then the most challenging part comes next is whether you put the ball back or not, and then you draw another ball, and it goes on, right? In reality, we don't do that. It's based on that, but we are working on more interesting questions. Like if you have an email, this particular keywords comes up, and you have to determine whether this is a spam mail or not. Yeah, and this is what we call probability theory, and we are trying to predict whether this particular, let's say you're using cell phone, right? You're using handphone, you're a Digi or Cellcom subscriber. We're trying to predict whether these particular users or customers will switch to another telco or not. Okay, this is what we call churning problem. And then the next one, we have descriptive analytics. So this is basically to understand your data set, to know like the average, minimum, maximum, and standard deviations, those sort of things. Now you might think like you either think that this is too easy, or you either think that, hey, this is something that I know. And yeah, just to tell you, this is what we do in data science in our daily jobs. We don't work on those super advanced problems like deep learning, neural network all the time. Yeah, a lot of time we spend on understanding data, cleaning data, rather than fixing the model. And to be honest, most of the problems we already know what model we are going to use. Yeah, we just need to gather and prepare the data. It's like cooking. You know what you are going to cook. You can't just walk into the kitchen without knowing what you want to cook, right? You already know what are the dish that you want to prepare. It's just that you need to figure out how to get the ingredients and whether you have the right tools to prepare them or not. And last one is the distributions. I think distributions, you all know, binomial distributions, Gaussian distributions, and then Pareto distribution, normal distributions. Yeah, this is to help you to understand your data. Okay, I spent a good 8 minutes to talk about what we do as a data scientist, but I'm going to tell you, right? Whether it's Python SQL or whether is it the mathematics and statistics, these are not the most important thing in data science. Okay, these two things you can pick up. Yeah, and there are ways to fast track. You can ask people and learn that relatively easier. But the hardest thing in data science, which is very relevant to your stage right now, is the domain knowledge. No matter which area you are in, I mean, whether you are from medical field, you are from mechatronic engineering, you are from data engineering, you are from information technology, you are from psychology, you are going to use data one day. Okay, some part down the road of your career. As simple as psychology students, right? You have to do a lot of qualitative analysis. You have to do ANOVA tests. You have to do t-tests. All those are part of data science. You can say that, oh, it's part of statistics. But yes, statistics is a subset or is one of the few in data science. Yeah, because we use that very aggressively. You need to know how to collect the data. You need to know how to massage the data, and it's not the other way around. Yeah, even though last time when we do SPSS, we rely a lot on that. It's just that we don't have a formal definition for data science at the moment. Why do I say domain knowledge is the most important? Think of anything that you learn, right, in your field. Let's say medical. When I built Corona Tracker, like Zion just said, I have zero knowledge about biology, as in virology, virus. So I need to spend like a good 3 to 6 months time, like really dive into it. Like spend 16 to 18 hours a day. I'm not kidding. On top of aside of building Corona Tracker, I really need to spend a lot of time to understand how the virus spread and the past cases. Historical cases like Spanish flu and all those kind of different epidemic, yeah, Ebola and those sort of things. And then and along the way I noticed that a lot of people, they didn't really understand the difference between virus and bacteria. See, yeah, I'm sure that a lot of our friends that they don't know too. I mean, by now they should have known, yeah. But before this, like 2 years ago, so domain knowledge is something that is uh, you cannot shortcut. You cannot fast track your learning. Like if you need 3 years to gain the knowledge to build out the good foundations on engineering or mechatronic engineering or electronic engineering, right? Then it takes 3 years. And when you go to work, choose a field or industry that you like. Yeah, you don't just choose data as an industry. Data is a very general industry. People who works in data industry will work with experts from other industries as well. So even though people portray data scientists as an expert, we may be the expert in data, but we have to work on other experts in other fields, other industries to solve interesting problems and to make an impact to the world. Okay, this is something that I want you to know. So out of the three things, domain knowledge is the most important one. And post-COVID is a time with a lot of opportunities. By the time you guys graduate, right? And these are the opportunities that you have not seen in the past. And with 5G, IoT, machine learning, AI, and things like that, you if you have something in mind, go ahead and pursue it, yeah, and use data as a tool. And the key here is when we have technical skills, right? Technical skills only help us to find answers, right? If you have a calculator, let's say you can get to know what is 1 plus 1 equals to 2. I mean, you get to know 1 plus 1 equals to 2, right? But domain knowledge helps you to ask the right questions. It helps you to understand what is the questions that you want to find out. And very simple. If you work in decimal, 1 plus 1 equals to 2, but you work in electronic, 1 plus 1 equals to 10, right? So if you don't have the right domain knowledge, you don't even know how to ask the right questions. Okay, I'm going to stop here for a minute and see if there's any questions. Yeah, feel free to drop your questions in the comments.
I think that maybe our audience is still is still thinking what is the question they have.
Yeah. That's how I was looking. Yeah, in case there's some delay. Okay, so if there's no problem, I'll continue. Yeah. Okay, so next part of data science, right? I'll say most of the people out there, they heard a lot on things like machine learning, AI, or the big data, all sort of things. But moving forward, especially as a data science graduate, one thing that you need to take note is there are a lot of people who are working in the data science field for the past maybe 5 to 6 years already. I mean, that doesn't mean that you don't have opportunity. It's just that we have segregated our jobs in quite a specialized field. So one of the things that can help you stand out among your peers is the ability or capability to do machine learning. So I'm going to walk you through a very simple things, a picture that will help you to get a good understanding on what is machine learning. When it comes to machine learning, right, we are using it to solve problems. These sort of problems comes from your business questions, like how to help the company to increase your revenue, how to help a company to save costs, how to help a companies to retain good customers, how to help your companies to find out what are the who are the employees who are going to resign. All right, these are the business questions or business problems that we want to tackle in real world. And when it comes to machine learning, you need to understand, you need to prepare one thing: your data. The data is the one that we use to train our models. The output of machine learning is models, and these models can be anything. You can is a mathematics equation that tells you that when you have particular input, you give an output. This is what model means. And when it comes to building the models, we have two major approach. Okay, we have two main approaches. Number one is supervised learning. Sorry. Now you use supervised learning. When do we use supervised learning? As the word tells you, supervised means that the process is under some supervision. So you already know, it's like a supervisor standing behind you. They will tell you that if I give you this, I'm expecting, or I expect to get value B. And if I give you C, I expect to get value D. And I give you E, I expect to get value F. So for example, they give you a data set that tells you like, this is the house with three bathroom, um, three bathroom, like large living rooms, and then three bedrooms, three bathroom, large living room, and this house will worth 500,000 ringgit. And then there's another house that's corner lot with uh, renovations, and then four bedrooms but only three bathrooms, and this house will worth 650,000. Okay, these are supervised learning, and this is what we call training data. All right, we have training data, and this training data it comes with label. And when we use supervised learning, we do two things. Number one is to predict something. When we predict an outcome, we predict an event, we predict a class, we predict a label. This is what we predict. And when do prediction, we use the method called classification. So let's say you are from law, okay? You're just a law student, and you want to know how data science is used in your industry, right? You can search for law, classification, data science, and these are the keywords that you can search. The technique is called classification, and the techniques, the models or the algorithms that we use, we have k nearest neighbor, we have logistic regressions, we have support vector model, and we have SPM, and then we have uh, decision trees as well. Yeah, so we have different types of models, and this is what we call classification. Now, sometimes we don't want to predict something. Okay? We don't want to know the outcome. We want to know a value, like the housing example that I gave you, right? We want to know if I have a house of this particular feature, what is the predicted price? Or if I have a wind speed of X, if I have a humidity of Y, what is the temperature of tonight? So this is what we call forecasting. When we use forecasting to predict the value of a future value, yeah, we predict a future value in a nutshell. And to do that, we can use regressions method. So the most popular one is linear regressions and quadratic, all sort of polynomial, different types of predictions. But overall, is under the umbrella of regressions. Okay, so you just have to remember, when you want to predict an outcome, you go for classification. When you want to predict a value, you want to forecast a value, you go for regressions. It's like you want to predict the weather tonight. That means the weather is windy, raining, thunderstorm, or still. Or you want to predict the temperature for tonight, which is forecasting. Okay, now sometimes you don't have the training data with you. You have a lot of data, but you don't have the training data. For example, you go to a company, right? Let's say Tesco, Aeon. They have a lot of customers transactions record, And because every day you have so many people come in and buy stuff, but they did not go and do anything to the data. They did not label the data. I said, okay, this customer, a good customer. The other customer come here, shop for 3 hours, eat a lot of sample food, but did not buy anything. Bad customers. They don't do that, right? But we have to do that for the customers because they have data. So one way that we can use is called grouping, okay, or what we call clustering. Clustering is a technique, and grouping is the task. So when we do grouping, what do? We want to group similar data points together. So like I said, we can do it based on behavior. Customers that behave similarly, we put them together. And then products that looks alike, we can put them together. And then people who have similar backgrounds, who have similar education level, financial status, we can do them together. We do that very often in um, CRM, yeah, customer relation management or digital marketing. Okay, so that's what we call grouping. And sometimes we want to do it on the product level as well. We want to know association. For example, uh, when people watch um, when people read a book, okay, when people read a book, say read Little Riding Hood, right? What are the other books that they'll often buy? Okay, they probably buy some Disney books as well. They probably buy some Aesop fables, and you know that okay, these are the people's that, books that people often buy together. And when you go to YouTube, you watch videos, right? It's using the same technique. People can watch YouTube video A, B, and C together, and then the other person can watch YouTube video B and C. So the similarity between these two people is that they have both watched video B and C. Now this user one, they watched video A. User two, he did not. So we can use this association rule to recommend YouTube video A to this particular user. And the same thing goes with Netflix as well. Okay, again, and like you go to supermarket, you realize that a lot of people they buy bread and peanut butter together. You don't know why. I mean, of course we know lah because the people had them for breakfast. But you have to use this association rule to help you to find out what are the products that are often bought together. You can put them into bundle and then sell it to your customers. All right. So these are I would say, all these things that you learn, it can handle 80% of the tasks that you will encounter at your work, especially as a fresh grad. You, you, chances are there are not that many companies in Malaysia are using deep learning or neural network unless you go for those very high end semiconductors or very high end tech startups. But usually they don't. Yeah. So when you are doing that, right? We can use this particular tool called Python. Okay, so I'm going to give you a walkthrough on how to use Python for programming. Yeah, for data science programming. Ziyuan asks, how about reinforcement learning? Is a skill needed by data scientists? Yes, but not that crucial at this stage because, like I say, right, I have so many clients. I hardly see any of them that really come and ask me like, hey, Doctor Lau, I need somebody that can do RL for me. Yeah, then those are usually used when you have like computer visions or driverless car, that sort of stuff. Yeah. And then Eddie asks if the domain knowledge is quite important for students who take bioinformatics course who have advantage than the one taking data engineering course. To a certain extent, yes, because you have the domain knowledge. So if you put the data engineering guy and the bioinformatics students guy in the same bioinformatic environment, that means let's say both of you go and work in a pharmaceutical company, of course you will have the domain knowledge and advantage. And that's why we always say, right, when you pick a course, it's going to affect your career. And that's why choosing a degree in for your bachelor is so important. Your first job is going to be influenced by your degree, but it doesn't mean that the data engineering guy it doesn't mean that he does not have the opportunities, or he does not have the freedom, okay, to apply what he learned, because there are a lot of things before it reached to the bioinformatics modeling, whether you are talking about protein, sequencing, that sort of stuff. There's still a lot of things that the data engineering guy can do. And put it this way, the data engineering guy, if you put them into like Azure or Grab, they look after the architecture, the data flow. They are the guy that know where to set up the pipes and where to set up the water taps for you in your house. Yeah, so they depends on what sort of positions they are working on. So they are both equally important role in the data team. Uh, I heard many people talk about data science and biology or medical field only. What are other hot domains that need data science and worth exploring now? So for you as a graduate, right, whatever industry that you graduated in or graduated as, you just go to that industry. You basically just go there, and that will give you a lot of advantage. Yeah. So biology and medical field is just you happen to hear it from them because maybe because of your friends around you, or maybe because of the knowledge they receive. And if you come to our side of the world, we handle a lot of things like let's say EV, right, electronic vehicles. We use a lot of data as well. We're actively collecting data, and you talk to people from, let's say, Bitcoin and cryptocurrency, they use a lot of data as well. Yeah, finance guys. Yeah. Yeah, Shirong said marketing. Marketing always data driven since 100, 200 years ago, because marketing is about psychology, is about studying the behavior and all this behavior. Now, people are irrational. Okay, don't think that people are rational. People are irrational. Okay. And yeah, that could be interesting. Okay, so, and I'll give you a minute to go to this website, collab.research.google.com. And this is the tool that we are going to use for the next 30 minutes. And then click on new notebook. I'll walk you through some basic concepts of Python and also how you can use that for data science. Okay, I'll give you a minute. Okay, welcome back. Now, let's go and do some interesting thing. So, first thing first, I would like you to try uh, Programming Language 101, print hello world. Okay? Printing hello world or printing value is very important in data science, because you always need to check and retrieve the value. And when you click that, right, it will start a mini instance in the cloud. So you can see that there's RAM and disk space allocated, which means you can start using this instance now. And this is a free service that's provided by Google, so you can simply use them, yeah, for any sort of I would say basic data science task lah. Okay. And then when it comes to programming, right, there are few things that you need to remember. Number one is, how do you store data? So Python is very straightforward. You don't have to worry about all those like integers or anything. You can just straight away allocate a value. So I would say name equals to Shahan, age equals to 25, and then merit equals to 4. So here, I'm giving you three examples, right? This is a string, okay? This is a string, and this is a number, and this is a boolean, okay? Yes, no. So whenever you want to run or execute a cell, right, you just press Shift Enter. Okay, a bit dry. I give you a minute. And if you have any questions, just drop them. Or if I'm going too fast or too slow, you want me to give you a slow motion replay, I'm more than happy to do so. You can click the play button here or just press Shift Enter. Yeah. Okay. And sometimes we want to store our values, not just a single value. This is the way that we store single value. We can use them to store multiple values as well. So we can say fruits equals to apple, banana, orange, and pineapple. And this is what we call a list. Okay, this is what we call a list. And some programming language we call it array. And there's another data structure called dictionary, which we can say person one, name, age, 25. Okay, this is a dictionary. And one cool thing with arrays and objects like lists and dictionaries that we can combine them together. So we can create another person or person two equals to name, Eddie, hey, age 18, married, hey, true. Then we can create another list called students equals to person one, person two. Okay. All right, I'm going to pause for a minute. Okay, no questions, eh? And now we can write a loop to process our data. So I can say for s in students, okay, print s. Or if I just want to get some value out of it, I can say print s name. And the last thing that I want to show you with Python is the if else statement, okay, to make decisions. I can say age equals to 18. So if age is greater than 21, say print, welcome to the club. Else, please go home. And when I change this, right, to 22, then you say welcome to the club. Okay. I'm going to share this notebook and paste the link in the chat so that you can see it. Okay, you can see that now. Okay, yeah. All right, let's continue. So when you are working, when you are preparing to get yourself a job, when you after you graduate, right, you need to build something called a portfolio. So in order to get a portfolio, you need to use real world data sets. All right, I don't recommend anybody using some uh, toy data set like the iris flower or the Titanic data set. Titanic data set is still okay, lah, to be honest. But the best one to do is to go to this website called kaggle.com. Okay, and then look for data sets, look under data sets. So give you a minute. Just go to kaggle.com and look at the data set and share some interesting one in the comment section. So I think this one is interesting, right? Rise image data set. So if you're into image processing, computer vision, then you can use this one. And I always use a lot of the data, business data set. So I use things like see analytics, employee performance, Titanic data set that we use that a lot also. Or you want to do something that's related to exercise, then you can look at this. Yeah, Fitbit, fitness tracker, mountain climbing data set, or you can get this finance data set, programming data set, tax data. There are a lot of data sets. Yeah. Okay, I'm going to give you 2 minutes and then look at kaggle.com, find some interesting data set and share with us. Then we'll continue after this. Okay, kaggle.com. Share the interesting data set in the comment section. Yeah. Okay, so let's continue. Let's go back to Python. Now, once you have found the interesting data set, right, you can just click into the data set. There are usually links for you to click and download. Yeah. Okay. You can straight away download them, all the data sets that you receive from kaggle.com. And let's go back to Python. And then I'm going to walk you through how to use Python to analyze some data. So in order to analyze data, right, this is what we're going to call the exploratory data analysis. Okay, EDA in short. You need to first import two packages. One is pandas and the other one is seaborn. Pandas is for us to perform data analytics, and then seaborn is for us to create charts, okay, create visualizations. And if you miss this, the link of this, if you just join us, right? I'm going to share this again. Plant village dataset.
Doctor, not
Okay, so
sure
once you have
why.
import that, right, you are going to provide the link to the dataset. If you have downloaded the dataset just now, you just come here and upload your dataset. Okay, you can just upload it here, or if you don't want, you can use the link that I'm providing you here. I uploaded it to GitHub, so you can use DF. Okay, read our data set into a data frame. So df equals to pd.readcsv, the URL that I've just pasted there. Whoa, YouTube chat can't send any URL link anymore. Seriously?
Yeah, doctor, not sure
Let me
why. I
try.
mean,
Let me try
I
on
still
my
sent a
own.
few link, but until now it's still loading. The chat message is still loading. It's not sent out.
Oh, really? Yeah. Every link that I've shared,
Yeah, actually,
you
we are
can
also
see.
waiting for a link.
Hey, that means all the link that I've shared earlier on, you guys can't see.
Yeah, actually, I'm not sure how about the audience. Can they see the link you share?
Okay. No problem. You can always heart failure prediction data set. Yeah, that one is pretty interesting. We use that a lot too. Okay. So if you want to get the link and everything that I've shared today, right? You just try contact me, Dr. Han now. You can drop me a message, okay? PM me in Twitter, LinkedIn, yeah, or Facebook. Okay, never mind. Because of time constraint, I'll just continue. Uh, uh, oh, that means you can't see my notebook also. Tricky. Okay, we'll figure this out. There must be a way. There must be a way for people to share links in YouTube. Okay, so what we are going to do here is we can. There's a very handy method that we can use to check our data. So first thing we want to do descriptive analytics. So we can do df.describe. And this will straight away give you all the statistical information that you want to know. Start from the count, mean, average, standard deviation, minimum, maximums, and then the 25% quartile, 50% quartile, percentile, and then the 75% percentile. Yeah. And then the next thing that we want to do is we are going to generate a correlation chart. So I'm going to show you a few tricks and techniques that we normally use as a data scientist when we are doing our work. Okay. So we're going to generate a correlation matrix using df.crawl method. And then when we call call, it's going to show us a correlation table. Okay. This is our correlation table. And then we can create a heat map. Okay, using correlation. So this is our correlation heat map. And you will notice that there are no numbers here, right? So if we want to show those numbers, we can call anode equals to true, and it's going to annotate our chart for us. All right. I'm going to pause for a minute in case you have any questions. And feel free to contact me after this workshop, okay? Drop me an email. Let me try if I can put email address.
Yeah, or maybe doctor afterward, maybe I will PM you through email or maybe other medium. Then you can share me the link. I will paste in the YouTube video description.
You see my email address in the chat?
I couldn't see it now.
You can't see my email address, you can't see my hashtag, you can't see my alias.
Yes, I couldn't see it.
Funny platform.
Yeah.
Yes, can a mechatronic graduate can definitely become a data scientist. Now you don't want to become a data scientist just anywhere, right? You want to become a data scientist in a mechatronic company. So you want to become the guy that knows data when you are working on mechanical mechatronic problems. Okay. All right. So let's continue. Yeah, we have a bit of time. Okay, I'll take some questions also. So the next one is I'm going to show you how to draw another types of charts. So let's say we can draw something called what we call a count plot. Now I'll leave it to you to do your own exploration. So I'll show you the tools. I'll show you where to get the data sets. I'll show you how we do basic exploratory data analytics. So you can use this as a starting point and then take it from here, lah. Yeah. Okay, so this is we want to look at the relationships between number of projects versus the reason why people are resigning from our company. So left is a column that we record whether the person resign or not. So we can see that people who work on 2 projects, they are very likely to leave, and people who work on 7 projects, they are very likely to leave also. So they are either underwork or they're either overworked. And people who work on 3, 4, 5, 6 projects, they are more likely to stay in the company. All right. And then the next thing I'm going to show you is the best part, which is how to build a machine learning model. So in this lab, we are going to use logistic regression model. So I'm going to say from sklearn.linear model, import logistic regressions. And then we're going to choose our input columns. So when we're building a machine learning models, you don't want to take every single thing. You want to pick some of the columns. So let's say we pick 3 different columns here. Satisfaction level, number of project, and then last evaluation. Right. So we are going to build our model by configuring the input and output. So our input is x equals to these 3 columns, and then y equals to this particular column. Okay. And then I'm going to call log model equals to logistic regression, and then log model dot fit train y train. Fit means you want to build the model. Yeah? You want to train the model. And then x y. And then from sklearn.metrics, import accuracy score, predictions equals to log model.predict, xtest, test predictions. Okay, so this part, what we're trying to do here is we're going to calculate the accuracy score. So once you have built a model, right, you need to know how accurate is your model. And then we are going to create some predictions based on X and Y. And it tells us that the accuracy of our model is 77.6. Yeah. Okay, or you take this time 100. Okay, 77.6%. All right, I'm going to take a 2 minutes break here before we continue. Let me know if you have any questions. I'll zoom. Yeah, you just have to look at this screen. Nutrition fact in McDonald's menu. No, there's no nutrition in McDonald's food. Where's the nearest McD near UTM? I know there's a Burger King nearby, right?
Yeah, just beside the Burger King.
Okay, so if there's no further questions, I'll go back to the slides. Yeah. So what you have learned just now is Python. I've covered the basics of Python and also how to use Python to build basic machine learning models. Actually, not really that basics. Build a logistic regression model that you can use. And contact me after this. I will send you the link of the workbook, and you can practice on your own. Now, after your graduation, right, when you look for a job in data science, there are many different jobs out there. Data scientist is not the only job in the market, right? There are data engineers, there are data analysts, there are data scientists, there are machine learning engineers. The importance of this role in a data science team, they are equally important. It's just that some jobs draw higher salary because they are rare. There are not that many data engineers in the market. There are not that many data scientists in the market, but there are a lot of data analysts in the market. That's the only difference. It's a supply and demand problem. Okay, it has got nothing to do with your job, nothing to do with your job title. They are all very important. You can't have a proper data science team without any of these people in there. All right, and if you wonder, I see a lot of questions that talks about, where can I do this, can I do that. Okay, I'm going to give you a quick recap on whether you can do this or not. So you assess that based on your business skills or your business knowledge, and also your technical skills or technical knowledge. So the jobs that require high technical skills and high business knowledge are jobs like machine learning engineers. Okay, you need to be very good at maths, very good at programming, and you need to understand the business really well in order to become a machine learning engineer. Otherwise, you could be building a model that is very good, but it cannot be applied to the business, or you is very good, but then when you go bring it to the business, it gives you crazy results. Okay, haywire results. And another position that requires high amount of business knowledge but relatively lower level of technical knowledge is data scientist. So when we work as a data scientist, you need to know a bit of programming, you need to know a bit of Python, SQL, but you don't need to know super advanced stuff like machine learning engineers. It's not that specialized. And if you are working as a data engineers, you, as I say, right, your technical requirements are not on those modeling stuff. It's on scripting, it's on managing the servers, it's on architecting, it's on setting up the cloud services and make sure everything runs fine. And your business involvement and business knowledge requirements is relatively lower. Yeah, you don't have to know a lot of those presentations or end user support stuff. And some positions that requires high business knowledge but relatively lower uh, technical skills are business analysts and data analysts. So if you know that you don't really want to touch technical things, you don't want to do also coding and stuff, then you can do data analysts and business analysts. There are other tools. I'm not saying you don't have to use tools. It's just you use different tools. Okay, so this one will give you a high level overview. And to summarize our workshop tonight, the few things is: number one, data science is a tool. Okay, data science is not it's not a magic. It's not something like, oh, it's so hard that you cannot learn. You just see it as a tool, right? You use it when you need it, and we use it to help companies to increase revenue or to save costs. And data science is not just about data scientists. Okay, other roles are equally important. These are the few takeaways that I would like to share with you, right? And let's go back to Q&A. I'll be here for another 2 to 3 minutes if there's any questions.
Yeah, I can definitely see question coming. So we have a question from
Can we
Mingli.
say that a quantitative engineering is data science in finance field? Uh, I'm not sure. Is it quite politically correct to do so, to say so? Yeah, but to a certain extent, yes lah. Quantitative engineering and then actual science, that sort of things. Yeah, and you do a lot of research, right? When you do quants. Yeah, so but you need to know specialized, uh, like, I think their requirements is more than what data scientists do in finance field. Yeah, that's how I felt. Yeah, especially if you're a quantitative analyst, right? Yeah, you need to know a lot more when it comes to your technical knowledge as well, and things like risk management, algorithmic trading, robo trading, that sort of thing. They are not easy. It's not somebody like me, right? Like a data scientist can easily just go in and grasp and understand. Yeah. Ming Lee asks, is cloud knowledge like AWS, Microsoft Azure important to data related jobs? Yes. If you are data scientist, data analyst, right, you need to know how to consume this service. You are a consumer, right? You need to know how to consume. And if you are a data engineer, then you need to know how to design them. You need to be a designer as well, because that's a lot to do with the architect. Yeah. So you need to know. But again, if I'm a data scientist or data analyst, my knowledge of cloud should be somewhere around 5 to 6. If you are data engineer, I would expect you to have at least 7 or 8. Yeah, out of 10, of course. Any other questions? 四鹏生活空间. Can bachelor straightforward become data scientist or must at least master? Bachelor is good enough. Yeah. in any event, right? I wouldn't recommend somebody to go from bachelor to masters. I said, okay, reset. In any event, I wouldn't recommend anybody to take masters. Yeah. Unless they know what they're doing. Especially if you take a master's in the same degree. You look at US, right? You look at all those senior management in those tech companies. They are their bachelor degree is usually like a technical skills. They got engineers, they got some like I remember Jeff Bezos. I think he's some, I don't know, aerospace or some engineering. I remember he said that in one of the videos, right? And then some of them they have physics degree. Yeah, so very specialized, very niche. They don't take business marketing in their bachelor degree, most of them. And then only when they reach their master's level, they took another MBA. That's usually what they do, lah. If especially for those people who are quite successful in the business world. I'm not saying if you do that the other way around, you cannot be successful, right? Don't flip it and think otherwise. It's just that when you take a master degree, you really need to know what is the value of the master degree and how this master degree is going to help you. And if I can share some of my experience, right? Don't take master coursework. No difference. Take master by research. You get scholarships, you get jobs, you get a much better life. Yeah. I hope as many people can hear this. I took master by research, and then it gives me a lot of options. I can go out and become a PhD, which I did, right? If not, I can go and work with a research degree. So yeah, it's probably the most valuable degree out there. How can a mechatronics student slowly transform to a data scientist along the way during university years? Any specific exams that you need to take? No lah. Don't worry, children, right? uh, when you enter the work world, right, it's not so much about exam. Exam is useful when you are were studying. I'm not mocking at the exam. Okay, exam is good. Exam is probably the it's not the most effective way, but it's probably the fairest way to assess somebody's skills level. Yeah, and of course it depends on the quality of the exams and certification as well. But that aside, right? Yeah, you don't have to transform to a data scientist slowly. If you follow what I have shared with you today, right, and apply in your industry, as in your work, in your final projects, and so on, yeah, you are well on your way already. You don't have to slowly turn into it. You can become a data scientist in mechatronic field right after your graduation. Yeah, if you follow, you can take a look at my other videos as well, and there are a lot of tips and career guides that I share. Yeah. Can networking students with cloud knowledge become a data scientist? Yes, but if you choose to study networking, right, and you have chose to learn cloud knowledge, you better off become a data engineer. That will maximize your knowledge. And if you switch to data science, then you have to learn other skills like programming, modeling, and maths and stats. Then only you can start to work. Otherwise, with your knowledge in cloud and networking, you can go straight to become a data engineer. Yeah, the pay is good. The pay is equally good. When you get a data science job, right? Okay, so here's how it goes. You submit a resume, and then they read a resume. Okay, then they get you. And HR usually spend 2 to 3 seconds to screen your resume. Right? You can look at my another video that talks about interview techniques, but they really just spend 2 seconds, 3 seconds just to okay. That's how fast they flip your resume. They receive like that many resumes every round. And then you will be called for second round interview. So second round interview or third round interview depends on the company culture. Some big tech companies like FANG, Facebook, Apple, Netflix, Google, all those, they have multiple rounds. Some people they do up to 3, 4 rounds. Usually one round is technical interview. So they will assess your technical skills. They will ask you to do some coding. In Malaysian company, most of them they are take home exercise, take home assignments. Yeah? So they give you a data set, ask you some business questions, and then you go back and get some results and share with them. That's usually what happens. And then the third round is usually the culture interview, like final check with you, make sure that you know what the company is doing, how do you see yourself in the next 5 years, that sort of things. And that's a standard interview process for most of the companies that are hiring data scientists. And in order to impress them, right, you should have you should have a portfolio, like a GitHub repository, show your side projects, so show people that what are the things that you do. Some people they like to see their employee contribute to open source. Some people they like to see people try out different things, like I'm applying for data scientists, but I do things like computer vision at the side. it's just personal experience. Yeah. So um, when I'm hiring, right, I go very easy. I just hire them for uh, a week or two, give them some projects. If they can do, they pass the probation, then yeah, we can take it. Mm. So, and the type of interview questions will also depends lah. Yeah, will also depend. Some, but if you talk about technical questions, right? Uh, the US side, okay, the other side of the world, they talk about lead code, all those things, programming, algorithmic. I don't see that often in Malaysia. I hope they don't get influenced that badly also. So it's more about the business side. Hmm. How many projects would be enough? I would say uh, at least three. At least three. If you have two, try to get another one or two. Yeah, it's not hard to create another data science project, right? So at least three or four. Yeah. And what kind of projects are best for showcasing? The best projects to showcase, right, is the one that's related to the company that you're applying. So let's say you're applying in a semiconductor company, right? Like let's say Intel. You're going to work in Intel. A couple of my students work there. When you work at Intel, you should prepare something that is related to manufacturing, related to predictive maintenance, okay, that sort of thing. That's two projects already, right? And then if you go for e-commerce company, let's say you want to work as a data scientist in e-commerce company, then you have to prepare things like customer profiling, customer segmentations, natural language processing, sentiment analysis, and these are some good projects. If you want to work in fintech company like digital banks, for example, then you have to prepare things like sales forecastings and financial analysis. Yeah. Just curious. Nah, you are not just curious. I'm sure that you are very curious and you want to know what is the common range of salary about junior data scientists in Malaysia per month. So, fresh grads. Usually, for well, if you let's say you're from a good school, right, famous school, UTM, yeah, 2.5, 2.8, no problem. Yeah, anything below 2.5, any offer data scientist offer below 2.5, right? You don't take it, you do some self-reflection and see what goes wrong. Yeah, see what went wrong. Data scientists cannot take anything that's below 2.5. Don't spoil the market, please. And especially with the current inflation, your salary should go accordingly as well, right? And some of the good ones, they get like top students, rising star, the dean list students, they get 3K, easily 3K. Yeah, easily 3K. And after 2 to 3 years, right, they will become a data scientist. That means they're not senior, they're not junior, they're just data scientists. Most of my students, they work in like Azure, those sort of companies. We get about 4.5K, 5K, 5,000 to 6,000. Yeah, easily. Data entry job is why? Come on, you're a degree graduate. Why are you looking for a data entry job? If you have not graduated, data entry job is fine. I do not discriminate job. It's about economics. No, you guys need to know about economics. It's about the best use of your time and resources. And you're fighting with millions of people out there who are capable of doing data entry. And data entry usually go by hourly rate. Yeah. If you want to know. It's about 10 ringgit, somewhere around there. 10 ringgit per hour. So if you work hard a day, it's about 80 ringgit per hour times 20 days. Yeah, 1,000, 6,000. That is just a little bit above minimum salary that will take place tomorrow, right? Yeah. No, usually it's the other way around. Usually they are looking for data entry, but they wrote the job description so advanced that looks like data scientist. Yeah, exactly. I know. I get what you mean. Yeah. Yeah, I can ignore those company. Your first job is important. It will have domino effect, affect your subsequent not to say subsequent jobs lah, yeah, but it will affect your subsequent decisions. Yeah, that's what I mean. If you pick the wrong job to begin with.
All right, I think. Okay.
Okay. Any other questions? I can take one or two more questions.
Yeah.
If not, I'll pass the mic back to Zivian. Okay, one
Yeah, I
more.
think we
Should
still
we
have
get
one
more
question.
internship during our studies? You get one solid internship to do, right? You want to internship at, I don't know, like you don't want to internship. You don't want to do intern at 2 to 3 small companies. You want to do intern at Facebook, and you can just, for the rest of your life, you can tell people that, hey, I'm an intern at Facebook. Yeah. I have students who got into Facebook internship, Grab internship, what else? And Firefox internships. Yeah, so it's the good one. You just need one because Malaysian system, they don't like to practice multiple internships. Like when my students, they go overseas, right? Like US, Canada, all those, they do internships like every summer. Yeah, so it's a bit different. So I would say don't get more internships. Some of the pay is like so little. It's not the best use of your time. I rather you take side projects. Go around, ask your lecturers, are they looking for any research assistant? Yeah, that's a much better use of your time.
All
When
right,
I
I
when I
think.
first went to Australia, I go knock at teacher's door and say, hey, are you looking for a research assistant? And yeah, I can help you to do something. Yeah. Okay. It might be off topic, but I'm curious. Is it possible to become a data engineer and also a DevOps engineer at the same time, since both are cloud related? Uh, you can switch lah, but not at the same time, because in terms of ops, right? There are DevOps, there are ML ops also. So if you want to stay in data science, I would rather you switch between data engineer and ML ops rather than DevOps, because DevOps is more related to web development, and you need to do things like what do you call it? The CI/CD, integration, continuous development, and then you have to worry a lot of things like GitHub, um, those managing the branches, and then understand the software development lifecycle, and then you have to do things like Docker, and then Kubernetes, launching virtual machines. It's totally different thing. Whereas compared to ML ops, yeah, is to look at the data, and is to look at the model, evaluation of the models, validate the models, and trigger some notifications and stuff. Yeah. So if I were to, not to say I were to suggest, if I were to pick a career path for myself, I would stay with data engineering and ML ops. Yeah, not DevOps. Quite a different career path already. Okay, I think that's all. Over to you, Zian.
Okay. First of all, very thanks a lot for Dr. Lau for his sharing, especially on his sharing how to begin a data science job. I think there's some especially domain part. I think especially I saw that many friends around me, they are kind of obsessed, including me, obsessed with the skill of improving my Python skill, improving my SQL skill, and we tend to miss out that actually what is important in data science is domain knowledge. Yeah, so once again, thanks a lot, Dr. Lau, for his sharing, and also through the Q&A session, I also learned a lot and has become clear that whether I want to become a data engineer or ML engineer. So I think that's all for today. And if you guys have any questions, feel free to feel free to reach out to Dr. Lau on his Facebook or LinkedIn or Twitter, Twitter handle. Yeah. I think that's all for today. Thanks for joining in and see you guys. Okay, bye.